going to do today, the booklet that you should have collected on the way in is another practice SAC. Same questions as the practice SAC that you've been given. They also mirror the questions that are on the SAC itself. Okay, it's pretty obvious what we're going to ask you because it's basically everything that we've done this term. Working our way from chapter 4 through to smoothing in chapter 7. Okay, so you should know what's on the SAC. All of you are going to be able to get the values, the calculations. I'm going to show you the way I do it, I guess. So it might be different to what your class teacher has shown you. You stick with what you know and what you're comfortable doing. But some of them you might think, oh, that's a bit easier, a bit quicker. And also I'm going to highlight the key things. So what is the question telling you, and how can you pick out the key words as to say, well, they want me to do this. Here's the template answer that I need to apply here. Here's the interpretation or what I'm looking for in the data to give my answer here. All right, so that's what the purpose of this is. I gave the data to you all via email yesterday. Some of you picked up on that. Some of you have entered it in now as you've walked in. So if you want to follow along, you can, but it's not vital, okay? Because you've got the answers in front of you. The point of giving you those answers and the handout is for you to be annotating what this question wants you to do, to highlight the key things so that you can add that into your all-bound reference. Okay, so you can use that alongside the practice SAC to highlight what it is that you do and don't know, and also have it ready for the SAC come Tuesday.
Can I add to that? The question in the SAC says, what is the R value? And you've got your practice SAC there that has an R value of 0.8. It doesn't help you very much. So having the word solutions isn't going to be what helps you do the SAC. Knowing how you got the 0.8 is going to help you. That's what Mr. Scanlon's saying here. Today you've got the answers in front of you. Things you should be writing down and highlighting are how do you get that value? Where do I find that from? That's the key to today.
Alright, cool. So, question 1 in these tasks asks you to add a 3 median regression line. So I've just put some pointers up there. You need to work out how many points did I start with, because you know with your 3 median regression you have to split your scatter plot into 3 equal sections. In this case it has 15 points, so that means 3 equal groups of 5. You don't have to work out exactly where to put those lines. The green lines, the green dotted lines down the middle, vertically in the scatter plot, are just to show where the breakup is. All right, it's not really important whether they're exactly in between 0.5 and 6. It's just a guide for you. What is important though is that you're showing us how then you go and find the median point for that lower, middle and upper section. So as you can see there, there's a little dotted green line in line with the third value working across and the third value working up. And where those two dotted green lines intersect is where I've put that pink cross. And that's the median point for the lower section. Then the middle, then the upper. So what we're looking for in this particular question, it's worth 3 marks. And so we're wanting you to show us how you've broken up the data, to clearly show the 3 median points with a cross, and then to put the line on the graph. The line must be parallel to the outer points, so the lower and the upper. So you line up your ruler there, and then a third of the way towards the middle point. And some of you might put little dotted lines in grey lead to give you a guide. We're basically looking for, is it the right gradient, and is it no more than halfway towards the middle? So that's the 2 key things we're looking for. And same with the examiners at the end of the year. Okay? So break it up into 3 sections, clearly show your lower, middle and upper median point, and then draw your line on the graph there. The second question then asks you to use your calculator or otherwise. If we tell you to use your calculator, that is a pretty big hint that you need to use your calculator to do this correctly. So I've got my data sitting in the calculator here. if I go into menu, statistics, stat calculations, this is where I would normally go to number 4 to get my least squares regression line, my R value, and my R squared value. If you go one item down from that, number 5, median, that gives you the 3 median line equation. I know you can also do this on the scatter plot, and some of you will have learnt it that way. So I've got a lot of data sitting in here in working ahead through this task, but I called my XList world, which I could just type, but anyway. And my Y list was US. Okay, so that's what I've called them. So here, the thing to note is that it gives you the median line in the form of Y equals MX plus C, which is the opposite way round to what the least squares regression line is that we ask you to find. So just be aware of that. MX, so M is the gradient, and the B value is actually the y-intercept there. Now, in terms of this question, we want not only the values to be correct, but in terms of the variables. So wherever you see the words in terms of the variables, that's where we want you to put world, US. Okay? The practice SAC, I think, was life expectancy and doctors per people. Is that the right set? Or that might have been a homework task. Can't remember now. But we want the words, not X and Y. We actually want the words. Okay? So you're looking for that keyword. 2 marks, 1 for the numbers, 1 for the words. So it's an easy 1 marker. Don't lose that mark 3 times throughout the paper. Okay? It's an easy one if you know you've got to do it each time. Okay, explaining whether a 3 median line is better or not. So just like in univariate data, we've got a way of finding some values using medians, and then we've got an alternative using means or averages. Whenever there is an outlier, the median is the better option. So disregard this question, or this set of data. The question here, and what we're looking for, is can you identify that median means outliers? So median as the preference is when there are outliers. So you go back to your scatter plot and you say, were there any outliers here? I don't think there were. That looks pretty linear, pretty together, I guess, is a way of saying it. There doesn't appear to be anything outside of that data set that's unusual. So that's why we've said here there doesn't appear to be any outliers. So either regression model would be appropriate. Okay? However, if your scatter plot had an outlier, you must say 3 median. Alright, 1D, use the equation that you found to make a prediction. So, I always say, even though in further maths, if you get the correct answer, you get full marks, no matter how many marks the question's worth. Usually only 2 at the most. But if you don't show me any working, and you get your answer wrong, then you get 0 out of 2. So, show the substitution. So show the line US equals 6.42 times 3.97 minus the 6.37, and then your final answer. Always go to 2 decimal places unless you're told otherwise. The exception to that is your R and R squared values, obviously, but always go to 2. If you are rubbish at rounding, go to 3. Make sure you write it down correctly. Okay, 1E, comment on the reliability. So, here with any prediction, we're looking for interpolation or extrapolation. Interpolation means it's inside the original data set. So the prediction of 3.97 falls within the original data for the world CO2. Therefore, it's an interpolation. If I asked you to predict what would be the CO2 emissions in the US when the world CO2 emissions was 7, that's outside the data, so extrapolation, not as reliable. Okay, so interpolation, more reliable than extrapolation. That's what we're looking for here. The second thing is, if you wanted to, you can also consider your R value. Now, you haven't been asked to calculate it yet, but you might have done it anyway. So if you've got a really good R value and your data looks linear, then any predictions made, particularly if they're interpolations, are going to be more reliable. Okay? Non-linear data, really low R value, or extrapolation, unreliable predictions. Okay? Alright, so that's question 1. Now we're moving into regression in terms of least squares. Here it's asking us using the data and the scatter plot provided. Now this question's worth 5 marks, so we need 5 things. It's not a simple one sentence answer, okay? You're not going to get that for 5 marks. Alright, so we need the R value because we want to use that to back up what we're saying about strength and direction. And then we need to refer back to our scatter plot and describe direction, strength, form, outliers. A lot of you forget form and outliers. So, our R value from our calculator, again, you might have been shown to find these values differently. But the way I do it, from menu in our stat calculations and number 4, linear regressions, again, we've got world, I called mine world, and US as my Y list. And here I get values for the regression equation, the R squared value, and the R value. So I get 4 pieces of information that I'm going to need. So you do the calculation once and it's all there. So in this case, the R value, 0.9279, round up, 4 decimal places. That falls into the strong category, it's positive. So we can say our scatter plot strong, positive, linear form based on looking at it. If you see a curve, then you say non-linear. Okay? Any outliers? We said no, there weren't any. So we can comment on that there. Okay, R squared value, again, just taken from that same screen. So 0.8609. Write it down. You don't have to. The question doesn't make you write it down. We're talking about the interpretation. Now, a lot of people don't understand when it says comment or interpret. It does not mean just state a number. We want a sentence. And in your notes, you should have a little template sentence that goes with coefficient of determination. We're expecting in this question that you know coefficient of determination means R squared. That's the first step. Then we're expecting you to go to your notes and pick out that little couple of line sentence answer that says the coefficient of determination R squared tells us that. Change it to a percentage. So 86.09% of the variation in the DV, y-axis, so US CO2 emissions, is explained by the variation in the IV, world CO2 emissions. It is always the same answer. Don't get fancy. Put the right pieces of information in. Okay? 3 marks there, 1 for the value, 1 for the sentence, a correct interpretation, and 1 for the correct order. Usually those questions maybe are only worth 2. Perform a linear regression analysis. That throws a lot of people. That's just a fancy way of saying find the least squares regression line. Okay? It tells you using the least squares method. Okay, so that, again, we've already done the calculation. We've got those numbers there for the regression line. So it's just a matter of writing it, and again, a throwaway mark in terms of the variables. So there's our, to 2 decimal places, our equations with the variables. Okay, when you have to plot the regression line, we actually tell you here, clearly show calculation of 2 points on the line. You can pick any 2 points, 2 values from your x-axis, so from the world data. Pick ones that fall inside the data that's on the scatter plot. So here I chose 4 and 4.2. It's quite a small range, okay? But that's what the scatter plot's showing me. So I've subbed it in, I've shown my working, and there's the 2 points that I've got. I then plotted those onto the scatter plot and drew a line through them. Okay, so we're looking for, in that type of question, the calculation of 2 points for 1 mark, the plotting of those points, and the correct drawing of the line for the other 2 marks. Does anyone know why I didn't join the line back to the y-axis? No? Yes? Yeah. Yep. Okay. We've actually cut the axes there. Okay. With the line, if I drew it back to the y-axis, it's giving a false representation of the y-axis intercept. So if you have cut an axis or broken an axis, you shouldn't draw your line all the way back. A little bit technical, but something to be aware of. Okay, interpret, a word we don't like. Interpret again means a sentence. Don't tell me the slope is 7.12 because I know that. You already told me in the previous question. We want you to interpret that. So again, template answers. On average, for an increase of 1 unit in the IV, so 1 tonne per capita in the world CO2 emissions, the US emissions increased by 7.12 tonnes. So we're needing to see it in that order, and you're saying whether there's an increase for a positive gradient, a decrease for a negative gradient. The intercept, again, don't just state it. You have to tell me interpret what it means, and then tell me whether it's a valid value or not. So in this case, when the world CO2 emissions are 0, the US CO2 emissions will be negative 6.4 tonnes per capita. I've said this is not valid because you can't have negative CO2 emissions. Now, you might argue technically means they're, I don't know, they're making more oxygen or something ridiculous like that, but we're not really interested in that. We're just, can you look at it and say, yes, it's valid or not? Okay? Another prediction, so same thing again that you've done earlier in question 1, but this time with your least squares regression equation, show the calculation. And now compare that. Alright, so comment on the reliability of your prediction and compare it to the one from question 1. If you see the word compare, you must actually show a comparison. Is it bigger? Is it smaller? Is it more reliable? Is it less reliable? Is it different? Is it the same? There has to be some sort of comparison. We're looking for that comparative sort of aspect to your answer. Alright. Question 3, we're moving into residuals now and residual plots and all that sort of stuff. Show a calculation of residual value by hand. So to show a calculation by hand means you have to show me the predicted value. So you're subbing in 4.17 to your equation to get a predicted value. Then you're showing me how you took the actual value minus your prediction, and there's your residual value at the end. You only will ever have to do that for one value, not a whole table, just one. Okay, so make sure when it says show calculation, they're the steps that you're doing. Now here we want the table of residual values, but there's only a couple of gaps you have to fill. So you're not going to, you could go through and perhaps calculate that, but you're going to have to plot a residual plot in 3C. So you may as well put the residual values into your calculator. Now, if you're like me and you've done lots of stuff in your calc, what we need to take note of in order to get our residual values, I've gone here to the, I call the grey box or the command line or whatever your teacher calls it, the grey box here, where my linear regression calculation was done. If I click into that grey box, you can see there at the end, the very last thing written says stat 8. So that means all of the residual value data, all of the extra data that goes along with that set of calculations is stored in stat 8. Okay, so if you just hit escape out of there, I'm going to go back near where my data is, and here in the grey box, I'm going to put in the residuals. The quickest way to do it is to go into var and link to. In there, it brings up all of the different variables that you've put into your calculator. Now I said it was stat 8, and I want the residuals for stat 8. If you're trying to follow along and you're not quite up where I am, we are recording this. You can go back and have another look, have a go yourself later, for anyone who's not sure how to do it. Okay, so stat 8, I press enter, and magically there are all my residual values. Okay, so I then just have to go to my table and go, all right, I need that one there to go alongside 18.29, and I need the one there to go along 19.91. Go back to my calculator, pick them out. The advantage of doing it this way though is that all of those values are sitting there, so now I can see on my calculator my residual plot quite easily. Okay? Alright, so values, residual plot, calculator. I've got a scatter plot here. I'm still showing my world, and I said it was stat 8 residuals. There's my my residual plot. Okay, so I've got a picture that I can use to guide, but I'm plotting that scatter plot by hand. Okay, so from my table on the previous page, plotting that residual plot. Now, in our residual plot, we're looking at this to test whether our original data was linear or non-linear. Because even if we see the scatter plot and it might look like a straight line form, and our R value is high, it's potentially a bit of a false reading. So we're looking at that residual plot and saying, is there a pattern? Does it appear random or curved? Also, once you've figured that out, is it evenly spread above and below the x-axis? Okay, so if we look at this one here, we've got a bit of a curve maybe. So it's starting off in the positives at the beginning of the x-axis, it's dropping down, there's more negatives in the middle, and then it comes back up again. So there is a bit of a curve happening. Okay, if we count the points above and below, it's pretty even, but there is that curve. So therefore that tells us that our original data was non-linear because there was a pattern in the residual plot. So no matter what it is, that's what you're looking for. Pattern, no pattern. If it's scattered, check above and below, number of points above and below. Random, even, means your data was linear. Pattern and or uneven, your data was non-linear. And that's what we're looking for. Okay, 3D. So based on my residual plot, my R value, everything else, what do I think about the suitability of a least squares regression line? So here, I've said it's not a good model based on the residual analysis. I probably should have said more. Let me cut something off. No, that's what I've given you. Sorry. Based on the fact that there is a pattern in the residual plot. Okay? Yeah, so 3D. 3D. Okay, transformations. So we've got 2 questions to go. Transformations, you are going to have to do all 6 transformations. Okay? What we're looking for, which one gives us an improvement in the R value, and also if we check the residual plot, helps get rid of that curved pattern. Okay, so which one improves the R value, and then when we refer to the residual plot, actually improves the overall picture there. So, depending on how you like to set it up, I've just done all 6 transformations there. Now I know some classes have sort of got an already ready-made template, but this sort of thing is pretty quick to do. You should be quick at squaring, logging, finding reciprocal of your variables. Okay? And then I've done the linear regression for each one. So I've gone through with my linreg and found each of those. What I have to write on my SAC though is the R value and the R squared value as a percentage to 2 decimal places. So there's my list there. If that's something you don't know how to do, then you need to be seeing your teacher tomorrow, Monday, Tuesday to clarify. But I know we've all done a lot of it in class. Okay? It is fiddly, and it's about keeping track of which one matches which transformation I've done, which set of statistics matches what. Okay, so based on that, if we look at the set there, we're looking at the best R value is world squared. and I've checked the residual plot and it looks pretty good, so that's what I've said. That's why I've chosen it, because it's an increased R value and the residual plot is slightly more scattered. That's what we want when you're picking one. Don't just say I picked that one because it's the best. Why is it the best? Regression analysis for that, again, in terms of the variables, but this time my data is using world squared. So I must write in my regression equation world squared. Okay, if it was a log of world, I'd write log, bracket, world, bracket. Okay, so make sure you write the transformed version of the variable, otherwise you'll lose the mark there. Again, when you're subbing it in, when you're making a prediction, make sure if it's a world squared like this one, I'm actually squaring that number, 3.97. Just be consistent and take your time with that, because these are not difficult things, but they are throwaway marks if you're rushing. Okay, again we need to compare our prediction. So always go back, it asks you to compare, so make sure you are actually doing that. Higher, lower, more reliable, less reliable. What do you think based on what investigation you have done? Finally, smoothing. So if we look at, and I haven't got the original data there without nothing on it, but that's our time series plot. So we can see there's a definite decrease from the beginning to year 6, then it increases again up to year 11, and then a decrease again. So that's what I've written, but using the appropriate years, not 6 and 11. Okay? You can say there's a general overall decreasing trend, but what we're looking at is what are the key features of the graph. The smoothing allows us to identify those overall trends. So it's not always obvious in the beginning. Okay, 3 median smoothing. Now some classes may not have done this yet. I know my class hasn't. We're doing it tomorrow. So 3 median is a graphical method. It means you do not use your calculator. You physically draw it onto the scatter plot, finding the median point, working your way across. Make sure they're clear so we can see them. Don't do your SAC in black pen and draw it as a dot over the top of the little squares and think we can see it. Use a different colour. Go over your answer in a thin highlighter or something so we can see what you've done. And we're expecting to see losing a point at either end because it's 3-point smoothing, so the first and the last will drop off. Okay, based on that scatter plot, did it actually do much for us? No, it basically follows the shape that's already there. So it's not a very good technique to reveal an underlying trend. So that's what we've said there. It's not appropriate because it really hasn't changed the data, so there's no point. 4-point centered. So here we've said all along you will not have to do one from scratch, you'll have to fill gaps. Okay, so a 4-point centered means, remember for the centered, the middle column there, you're taking 2 points above, 2 points below, then averaging them to get the next actual centered value. There's only 2 more things, we'll keep going. Plotting that, so this time, if you look at this plotted smooth data compared to that one, it's much smoother. You can see that trend, general trend, much more clearly. Okay, so that's what we want to say. It has been a better technique. Underlying trend, there's an underlying decrease, and why do you think it exists? Just use your common sense in those sorts of comments. All right, generally it'll be quite obvious and quite easy to come up with a reason why things are changing. Okay, I know a lot of you have got to go. Thank you for coming today. If there's anything you will need to know in follow-up, make sure you see your teacher, and good luck for Tuesday. Thanks, guys.